All right, now it's time to answer number 6. We didn't get to it in class, so I'm going to walk you through how to solve this problem, and hopefully it makes a lot of sense because I like this question. So what we're dealing with here is now a horizontal directional motion of a train, and we've got two different tensions, and the tensions are FT2 and FT1, and the question would like to know the ratio between those for any non-zero acceleration. And so the way you approach a problem like this is you need to actually create statements for each of these tensions. And the best way to go about this is to possibly make force diagrams and see if you can make some sense out of those. So if I draw this force diagram on card 2, obviously we have the force of gravity and the normal force. They're not really relevant in this problem, but they exist. And we have a force of tension, which is tension 2, pulling to the right. That's the forces acting on car 2, because we can ignore friction in this problem because it's on wheels, the wheels are rolling. More about that on another time. Now the force diagram for car 1 is going to also have this force of gravity and the normal, and it's being pulled to the right by force of tension 1, but it's being pulled backwards on by tension 2. So there are two force diagrams. So what I'm going to do now is I'm going to write a statement for the acceleration of each car. So for the second car, force of tension 2 is actually equal to the mass times the acceleration of the second car because it's the only force pulling the second car. Now I'm going to write a statement for the first car, and in this case the force of tension 1 minus the force of tension 2 is equal to the mass times acceleration of the first car. Now, I can rewrite this to be ma plus ft2. Now, what I'm going to do is I'm going to substitute this ft2 right there into where ft2 is in the other equation. So by doing that, I end up with a statement of ft1 equals ma plus ma, which is equivalent to 2 ma's. So now I know that ft1 is 2 ma's, and I had previously written that ft2 is ma. So if I need a ratio of ft1 to ft2, I can write what these two were equal to, because ft1 was equal to 2 ma's and ft2 is equal to ma. M cancels, a cancels, and this works because the statement claims that the cars have the equal mass, so therefore this is a 2-to-1 ratio. So my answer is 2-to-1. That's the ratio for any non-zero acceleration between the two tensions of the cars.